What's going on, guys? Andy here. I'm here with my little assistant and we are going to solve a more special and a little bit different problem on LeetCode, which is an interview question asked super often by companies like Amazon, Google and Facebook, and it is called the minimum cost to hire K workers. And make sure you stick till the end of the video because I have a special giveaway for you. Let's jump into it. As you can see, the problem is tagged as hard, but no problem is too hard for us, right? So, there are n workers and the ith worker has a quality of I, and the minimum wage expectation, wage of I, right? Because everybody has minimum wage expectations. Now, we want to hire exactly K workers to form a paid group. When hiring a group of K workers, we must pay them according to the following rules. And the first rule is, every worker in the paid group should be paid in the ratio of their quality compared to other workers in the paid group. So, this can be a little confusing. Let me explain it a little better. Now, let's say you have two workers, right? Worker A and worker B. What this means, that worker A is paid in the ratio of their quality compared to worker B, is that the wage of the worker A divided to the quality of the worker A should be equal to the wage of the worker B divided to the quality of the worker B. And this should hold for every pair of workers you choose in your set, right? Now, the second condition is that every worker in the paid group must be paid at least their minimum wage expectation. Definitely. Return the least amount of money needed to form a paid group satisfying the above conditions. Okay, and the first example is, we have 3 workers, their qualities are 10, 25, and their minimum wage is 70, 50, 30, and K equals 2. Now, their answer is 105. And they say, we are choosing the 0th worker and the second worker, right? Pay 70 to the 0th and pay 45 to the second. First of all, 70 plus 45 is 105, and let's check the first condition. 70 divided by the quality of the 0 worker, which is 10, equals 7. 45 divided to the quality of the second worker, which is 5, equals 7. 7 equals 7, which is right. Now, let's check example number 2. 5 workers, the qualities are there, wages are there, and K equals 3. And they are choosing the 0th worker, the second, and the third worker. Perfect. Now, we pay 4 to the 0th worker. That means 4 divided by its quality, which is 3, should be equal to 13.333 period 3 divided by the second, which is 10, and 3 point period 3 divided by 10, which holds, right? So, these are the examples, guys. Now, let's jump into the solution. And I'm going to take the first rule, because it's the most important one, and rewrite it a little bit. Now, what did we say the first rule means? That the wage of the first worker divided by its quality is going to be equal to the wage of the second worker divided by its quality, and so on and so forth, going to be equal to the wage of the kth worker divided by its quality, right? So, all of those are going to be equal to, let's say, an X. And what do you think this X is going to be? This X is going to mean the wage per quality unit, right? So if I have a worker which has quality 10, its final wage is going to be 10 crossed X. So if I have a group of K paid workers, the amount of money that I need to pay all of them is the total sum of their qualities crossed this X. But I don't get to choose this X. This X is going to be based on the minimum wage expectation, right? So, if let's say I have a worker and he has a minimum wage expectation, right? And the quality, this means that the minimum X expectation for this worker, right? So, the minimum wage per quality unit expectation for this worker is going to be the mean wage expectation divided by its quality. And each worker has this number, this property. So now I know the formula for the amount of money I have to pay my group of K workers. And it is, if I choose K workers, I have to take the maximum between those minimum X expectations in order for all the workers to be satisfied, right? So the maximum between mean X expectation for everybody crossed to, as we said, the sum of their qualities. So sum of qualities. So this brings me the following idea. For each worker, instead of knowing its minimum wage expectation and its quality, it's more useful to know its minimum X expectation and its quality and sort all of this by the minimum X expectation. Now, if I do this and afterwards I choose k workers, let's say their indexes are I1 less than I2 less than dot 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 less than ik, I know that that maximum between all those minimum x expectations is going to be the mean x expectation of ik, because we sorted them increasingly, crossed the sum of all this, right? So let's say quality of I1 plus quality of I2 plus dot 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 plus quality of ik. And I need to minimize this product. Now, in order to do that, I need to know at least one information. And I'm going to choose mean x expectation of ik. So in order to know this, I should fix, of course, ik, right? So I will make a for loop in which I fix the index of the last worker that I take. In this way, I know the minimum x expectation, and what remains is to choose k-1 other workers with their indexes between position 1 and position ik minus 1, such as the sum of their qualities is minimum. So what does this mean? That I will choose the k-1 workers with the minimum qualities from this range. So I'm iterating through my workers, and for each worker I need to know the first minimum k-1 numbers. And how do I do that? Well, let's say I am at some current worker and I have my set of k-1 minimum qualities. When I go to the next worker, now the quality of that previous worker becomes available. So what could actually happen is that this quality should be part of the set. So this quality is less than the maximum number from this set, so I should remove that number and insert mine. So I'm going to need a data structure which holds for me those k-1 numbers, which allows me to know very fast what is the maximum number between those, allows me to remove it if necessary, and allows me to insert elements into it. And you've guessed, this is a max heap, or in the STL library, we call this a priority queue. So we are using a priority queue. We are iterating through our workers after sorting them by the minimum x expectation. And for each current worker, we check if there are exactly k-1 qualities in our priority queue and the maximum quality is greater than the quality of my previous worker, I should insert that and remove this one. I should update the sum, and in the end for each current worker, so for each possible minimum x expectation, we are updating our answer. Let's write the code for it now. We are initially given the vector of qualities, the vector of wages, and our k. And as we said, we are going to redefine those workers as being x and quality. So first of all, let's take the number of workers, which is the size of these vectors. So n equals quality.size. Then I will define another vector of pairs of double and integers, which are going to be called workers. And for each worker, starting from position 0 all the way to position ni++, in those new vector workers, I am going to add a new element, which is a pair of double. And this x, as we said, is the minimum wage expectation divided by the quality of this worker. And the second one is just going to be the quality, right? So quality of I. Perfect. Now, second step, we are going to sort these workers. So workers.begin all the way to workers.end. And as we know, when we are sorting pairs, they are going to be compared by the first element and then by the second one, which is exactly what we want here. So I am going to have my variable sum, which is always going to be the sum of my qualities, so the sum of those minimum k qualities, and my answer. Initially, my first valid set is consisting of the first k workers, right? So I am going to, through those first k workers, I++, and I am taking them into my set. So sum plus equals is going to be workers of I dot second, which is the quality, and I'm going to insert this quality into my priority queue. So let's define that first. So priority queue of, it's going to be consisting of integers, let's say mean qualities. Perfect. Now, mean qualities dot push of workers of I dot second. Perfect. After this, let's initialize our answer. So answer is going to be equal to sum crossed workers of k-1 dot second, right? So it's always the sum of the qualities crossed that maximum mean x expectation. And after this, let's iterate through the other workers. So starting at position k, all the way to position n-1 I++. And what shall we do here? We will take the maximum quality from our priority queue. So integer max quality is min qualities dot top. We are comparing this max quality and see if it's greater actually than workers of I dot second, and if that is, we shall remove it and insert the new one. So we are going to have here min qualities dot pop, so remove that one, min qualities dot push of the new one, workers of I dot second, right? And we are going to update our sum. Super important, don't forget that. So sum plus equals is going to be equal to, I'm going to have workers of I dot second minus what I've removed, which is the max quality. Max quality. Perfect. After updating the sum, I should update the answer too. So the answer is minimum between the answer and sum crossed this current workers x, right? So in the end, after doing this, I should return my answer. And let's run the code for this. Finger crossed. Let's see if it works or not. And it does. Let's submit it. I've already solved it 3 months ago. So it's quite fresh, let's say. And I have a wrong answer. So, big mistake here. This is going to be first true, right? Because I'm taking the x. Now, let's submit this one. Hope for the best now. And it worked, guys. Faster than 90%. Wow, this is awesome. Alright guys, this was the problem minimum cost to hire K workers. It is again an interview question on LeetCode asked super often by Amazon, Facebook and Google. And now for the special giveaway, you just have to share this video on Facebook and write me in the comments what is your favorite LeetCode problem. Also guys, make sure you support this channel, and if you really like the content, hit that like button, hit the subscribe, and I can't wait to see you on the next video. Bye.